All right. Let R be the region in the first quadrant bounded by the graphs y equals square root of x, y equals 1/3 x, with cross sections perpendicular to the y-axis. Perpendicular to the y. So perpendicular to the y-axis. This is y. So this thing is gonna go like this. Okay, so it's gonna be dy that are equilateral triangles. What is the volume of the solid? Okay, so volume integral, and it's dy, no? So because it's gonna go dy, those things. So area, gotta get the lower and upper bound. Zero. How do we figure that out? How do we figure out the upper bound? Yeah. So how do we do it? Set them equal to each other here, no? So square root of x equal x over 3. Well, it has to make sense in this particular situation. You don't need a calculator because it looks to be 3, and if you actually do plug in 3, square root of 9 is what? And then 9x is what? X over here is 9, and 9 divided by 3 is 3, so 3 equal to 3. So in this particular situation, you don't need to do the calculator thing here. So it is going from 0 to 3. What was that area for equilateral triangle? Where's your no code worksheet I gave you? You should know it. It's in there. It was what? Square root of 4 over 3, is it? No, it can't be square root of 4, because then it would be 2. Square root of 3 over 4. So then, hold on here. It was square root of 3 over 4 s squared. Is it? So we're gonna go volume equals from 0 to 3. Area is square root of 3 over 4 s squared dy. Okay, so this is s, no? This is s. So what is s going to be? What is s? What should I write down as what s is here? Well, isn't it the line? Because it's always the right minus the left, no? So it's going to be the line minus the square root thing, but it's in terms of it's gonna be in terms of y. So we have to switch everything in terms. Everything in terms of x, no? No, in terms of y, because we're doing dy, no? Dy, so everything got to be in terms of y. So here x is gonna equal to 3y, isn't it? Times it by 3 here. X equals 3y. So it's going to be, this will be 3y. And this one is going to be what? Solve for x will be what? Fold it and square it. Y squared? So it's going to be what? 3y minus y squared. So we go here. So this is going to go from 0 to 3. Square. Could have factored that out already. Whatever. Square root of 3 over 4. S is 3y minus y squared dy. Okay. You know what? Put that in the calculator. Get your calculators and put that in the calculator. See if we get this. The other one. What is it?
Yeah, 3.5.
Is it 31507? Okay. Let's move on. Volumes with disk method revolving around the x or y axis. So volume with disk method revolving around the x or y axis. So at the beginning of this semester, we talked about trying to find the area under the curve of a quadratic, like say y equals x squared, and it was from 0 to 1, but now let's kind of go from 0 to 2. So what's the area under that curve? That should be pretty straightforward. So just finding that area would be the integral from, if we do these vertical rectangles here, it would be from 0 to 2, from 0 to 2 of what? It would be what? The quadratic, no, x squared minus 0. That's why usually you want to, if you really want to think about it, this right here is x equal to 0. So we subtract 0, so there's no point of subtracting 0 because it doesn't do anything. So it is x squared minus, so it's x squared and then dx, because we're going dx, we're adding up these rectangles, we're going dx. So that's the area under the curve here for that, no? That's what we know. But what would be if we rotate this thing around this x-axis? So if we rotate this thing, you're going to get a spinner. That is, you'll see it's like a kiss. Look, here we go. So if we rotate this around something like an axis, then you will get this graph. Watch. You'll get this. Okay, it's talking about the formula already. So here's the formula, I guess. I was going to show you the picture. So it's going to create a volume, and it is going to go from A to B. I guess it's going to go from A to B. And it is pi r squared dx for this particular one. That's if it's going, if it's going dx. So pi r squared, where r is the radius. And there it is. As best I can draw something, it's like a spinner that you tilt it to the side. And that's supposed to be like a circle here. As best I could draw a circle. So yeah, that's what it creates. And there's a general formula for it, and that's kind of it. r of x is the radius, no? The radius is the radius of this thing, and it keeps changing, but it isn't the function. That's it. When r of x is the radius between the axis of revolution and the surface of the solid, as we keep adding up these circles from A to B. All right, whatever. Let's go. That's it. All that. And so for this particular one, it would be A equals A. We're going from 0 to 2. So this would become the radius. This is r of x. And then so it's going to become pi radius quantity squared. And x squared is here. X to the fourth, pi x to the fourth. Right here. So there's that. There's that. Okay. Let's do one example. So what if we take the region bounded by y equals 4 minus 2x, which is that line that is the green line there, and then it's bounded by y equal to 0, x equal to 0, and we revolve this region about the y-axis, and what is the volume of the solid of this region, and it's going to become, you know what, I do have a picture for that. Actually, I have it here. So somewhere, it really is this right here. Right there. That right there is going to become this. Because all you see is like this side right here, and then it's just one dimensional. So you just see this triangle or whatever. But once you rotate it, it will become this. And then at the bottom will be a circle. So that's really what it is. And you do that, and we rotate that thing, and there it is. That's what I just showed you. And so what is the volume of that shape right there, which is a cone? Okay, so what is the volume of the solid region? Okay, so we're rotating this thing around the y-axis. So this is going to become dy. So the volume will equal to the dy, and it's going for, so dy, no? Here dy is going to go from 0 to what? Up here at the top. From 0 to what? If x is 0, then it has to be 4, yep. Then y is 4, yep. So then we do pi, and the formula says pi, the radius, but it's going to be r of y, not r of x squared. So the volume will equal to 0 to 4. You could always kind of factor out that pi. And r, what is going to, okay, so r is the actual function. So we got to solve for, it has to be in terms of y. So you're going to get what? Y equals 4 minus 2x. Solve for x, so everything's in terms of y. So I'm going to move the minus 2x, move it over this way. So it'll be 2x and minus the y over that way. 4 minus y and divided by 2. X equals what? 2 minus y over 2. That's the way I just quickly is the algebra of this. So this is going to become the radius. This is what r of x is. R of y. R of y is going to be, then plug it in. It'll be 2 minus y over 2 squared dy. And let's do this, put it in a calculator. You guys put it in a calculator and let's get the answer for that. you guys getting? Mm, yeah, probably because pi is 3.14 and 3, and then they cancel is a 16 point something. All right. Okay, and that's that. Let's go to the volume with disk method, revolving around other axes. Basically, it's a shifted one. If it is not revolved around the y-axis or the x-axis, this is the x-axis, it's been shifted. So it's been revolved around, let's see where this one is revolved around. It's been revolved around the x equal to 2. Okay? So it's not being revolved around the axis. It's revolved around x equal to 2. So basically, it's nothing really complicated other than it's always subtract the top minus the bottom, or you're subtracting the left from the right. Okay, it's left subtracted from the right, or subtract the bottom from the top of the things. So this one is going to be dx. It's going to be dx, and basically the radius now becomes the top, which is going to be this green radius. The radius will be the top minus the bottom of these things here. Whereas before it was 0. That's why you didn't care for that. But now you're going to have to do the function minus 2. Let's see. Let's go over here. Let's give you the formula then. So it's the outer function minus the inner function. So it's the same formula. Volume equals from the integral from a to b pi r squared, but this r becomes the outer minus the inner when it's not revolved around the axis. Everything else staying the same as was done when revolving around the x or y axis from the previous lesson. So it's just knowing it's outer minus inner. In this graph, the equation of the parabola. So the equation of the parabola is y equals x squared plus 2. And the graph of the line is y equal to 2. And so it's going to be the outer minus the inner. And so basically it's the same thing, because 2 minus 2 is going to cancel out. So in any case, we want to revolve around the line y equal to 2. If that's what it's asking to revolve around the line y equal to 2. Outer minus the inner. Outer is the parabola that's been shifted up to, because this parabola has been shifted up to. And then minus the y equal to 2 line, horizontal line. It's the same thing. It's the same idea. It's just that you just got to know that the top minus the bottom, and then it's pi r squared, where r is the outer minus inner. And it's whatever. It's the same answer. Turned out to be the same answer. It would be the same answer as the other one that we just did. All right, let's do last one here. Here's the last one we're doing today. The area bounded by the x-axis, x equal to pi by 2, y cosine x, is revolved about the line x equal to pi by 2. Find the volume of the resulting solid. the area bounded by the x-axis. X is equal to pi by 2. Y cosine x. So sine goes up and then down. Is revolved about the line x equal pi by 2. So it's revolved around this. It's going to look like a helmet when we revolve it. So there it is, like a soldier's helmet or something, I don't know. What does it look like? Then what does that look like? What is it? Like a hat. So the bottom of it is it will be a circle. All right. So how do we do it? All right. Well, it's better to just look at it like this than the actual this. Yeah, this, because then it's telling us what to do here. Okay. So is it gonna be dx or dy? How do we quickly know? It's revolved around x is equal to this, revolved around this. So they're going to always be perpendicular to this, like this. So it's going to be, and then you're going to do a bunch of these. It's going to be dx or dy? dy. So this is going to be dy. And it's going from where to where? The lowest 0, no? And the top is what? Isn't it 1? Because sine x goes all the way to 1 at the top, no? 0 to 1. So we're gonna do what minus what? See, it's gonna be what? Pi by 2, isn't it? Pi by 2 minus what? It's gonna be, because we're subtracting the right from the left here, so it's gonna be pi by 2 minus what? Y cosine x. Okay, look, y cosine x is so it's y cosine x, and it's dy. We gotta change everything. X equals something. It's gonna be sine inverse, no? Sine inverse of y is equal to x, like the inverse of that. So you put pi by 2 minus sine inverse of y. So this is going to be pi by 2 minus sine inverse of y. Hold on, did I do it? And then it's what? That's going to be pi r squared dy. So 0 to 1 pi, and then the inside pi by 2 minus sine inverse y squared. All right, yes. So put that in the calculator. What's going on, Crystal? Your calculator doesn't work or what? Huh? What? Also, it's not working? It's dead? What'd you guys get?
3.6.
What the heck? Ah, oh, so look, I got it backwards. It's still the same answer, didn't it? It's not. It's not. It's not the same answer.
It's just off by like
By how much?
0.1.
What'd you get?
3.623.
What's the problem? What did I do? I said, what did I do? Hold on, let me go back to what I did.
Put the high over to
Okay, look. What's outer and what's inner? What's outer and what's inner? And what did I do? I did this minus this. You got it's like it's in reference. What's outer and what's inner? You got something like this, no? And you got a graph going like this or whatever, which is that. That's outer and that's inner, no? It has to be. And if it was like this, if it was like saying like this way, which one's outer? That one's outer. This is inner, no? The inside. Go ahead and do it the right way. See if we get maybe does it make a difference? I don't think it makes a difference though. But the answer's still wrong. But anyways, make sure no matter what, the inner is the inside, and then the outer minus the inner. That's just, yeah. The answer should still be the same.
Oh, I got it right now. I put multiplications and minus.
So, but it still should be the same, the answer.
Yeah.
Why would it be the answer? Because you're squaring it. Because you're subtracting it, it's going to be some negative, whatever. But you're squaring it, it doesn't really matter. But just to be more exact, if you got some this is the outside and the inside or whatever. But all right.